Hi everyone, my name is Namakula Josephine. Today, I'm going to take you through the application of RAG in financial decision making. So when I go to the introduction, RAG in full, it is a retrieval augmented generation, which is a technique that combines the capabilities of a pre-trained model with an external data source. This approach combines the generative power of LLMs like GPT-3 or GPT-4 with the precision of specialized data search mechanisms, resulting in a system that can offer nuanced responses. A language model is a type of artificial intelligence designed to understand and generate human language. Natural language processing is a field in artificial intelligence that focuses on the interaction between computer and human language. It involves the development of algorithms that enable computer to understand, interpret, and generate human language. It includes concepts like tokenization, stemming and lemmatization, part-of-speech tagging, named entity recognition, parsing, sentiment analysis. So tokenization, you can say it is a process of breaking down the text into individual words or tokens. Stemming and lemmatization. They are techniques to reduce words to their root forms. When I go to the problem statement, in financial decision making, it is crucial to retrieve relevant information quickly and accurately to support decision makers. However, existing systems often struggle with handling unstructured data effectively, providing interpretable and contextually relevant information, integrating seamlessly with advanced AI models for generating insights. Also, traditional financial decision making models rely on rational agents and efficient markets. Behavior finance presents contradictory empirical evidence. So the related works, one was improving language understanding by generative training, which introduced the generative pre-trained transformer, a large-scale language model that addresses data scarcity, transfer learning limitations, scalability, and generalization challenges through a two-stage training process involving unsupervised pre-training on a vast text corpus and supervised fine-tuning, showcasing impressive capabilities in various natural language processing tasks and significantly advancing the field. The second one focused on enhancing retrieval mechanisms for RAG models in financial documents. They identified the problem of traditional methods failing to capture relevant and contextually rich text chunks. To overcome this, they developed advanced chunking techniques considering document structure, employed hypothetical document embeddings for better query expansion, and utilized metadata notations and relinking algorithms to prioritize relevance, significantly improving the retrieval accuracy and overall performance of RAG models in financial question answering tasks. So the research questions were, how can we effectively retrieve relevant financial documents from a large corpus to support decision-making processes? How can we integrate advanced text generation models like ChatGPT-3 with a retrieval mechanism to produce accurate and contextually relevant responses? What are the effective preprocessing steps to enhance the quality and relevance of retrieved financial documents? How can the performance of RAG model be evaluated in terms of retrieval accuracy and generation quality? So the research objectives were to develop and implement a retrieval system to enhance data quality through preprocessing, to combine the retrieval mechanism with a powerful text generation model, which was GPT-3, to generate informative and contextually appropriate responses based on retrieved documents. The fourth one is to identify and tackle challenges such as handling unstructured data, ensuring system scalability, and maintaining response interpretability. So the research contribution, we applied a novel integration and retrieval. We apply a novel integration of retrieval and generation where we combine a term frequency, inverse document frequency, vectorization, and GPT-3. We implemented a document retrieval system using term frequency, inverse document frequency vectorization, and consign similarity, specifically tailored for financial documents, designed and implemented a user-friendly front-end application using React, enabling seamless user interaction. Features include real-time query submission, response display, and session management, providing an intuitive interface for users to engage with the financial advisory system. And the back end, where we used a Flask application, introduced a session management system that retains the context of previous interactions. This feature allows the model to incorporate past queries and responses, providing more accurate and contextually enriched answers and updated the latest version. When I go to the next slide, I find data collection and preparation. The data source, I scrap the financial documents stored. The data source financial documents stored in an SQLite database, where we scrapped PDFs about financial decision making these financial documents, which were stored in an SQLite database. The data used the data is then loaded and cleaned, which involved text cleaning to remove noise, stop word removal to eliminate common but irrelevant words, lemmatization to reduce words to their base forms. The retrieval mechanism, vectorization, the use of TF-IDF vectorizer to convert documents and queries into numerical vectors, consign similarity to measure the relevance of documents to a query, and retrieve the top n relevant documents from the SQLite database. The augmentation technique, it was the contextual augmentation, particularly through the use of contextual embeddings, which is a technique used in modern natural language processing to enhance the understanding and preprocessing of text by capturing the context in which words appear. And this helps in providing richer, more nuanced representations of words and sentences. The RAG framework overview. Here we have a prompt from the user. We vectorize the prompt. We go to the document retrieval, context generation, up to ChatGPT, where we get the response from. The methodology. This is the methodology. Here we load the collected data. This is that we create our vectorizer. We create the vector embeddings into our to our SQL database, where we go to the retriever, retrieve context. Here the retrieve content is put into the LLM, from which the external data was also put into the LLM, and here we concatenate the query and the prompt back to the LLM, and here we got the response from we put the where we got the formatted response from the user interface, up to the user, and the user gets the response. Application of RAG in financial decision making. The RAG system is designed to assist financial analysts by providing relevant information and insights. The example queries which can use what are the recent trends in stock market, provide an analysis of company X's financial performance. When I go to the next slide, I find the implementation details. Back end, we use Flask server for handling queries and managing the RAG processes. Front end, it was React application for user interaction, and APIs and Open API for GPT integration. Experimental results, the evaluation setup, testing the system with various financial queries. That's what I used. And also the metrics, measured retrieval accuracy and response relevance, and also time. This is the user interface we designed using React. This is the also the user interface with question asked from the RAG applications. The conclusion, the RAG framework offers a promising approach to financial decision making by combining the strength of a retrieval and generation, the strength of retrieval and generation. While it presents several advantages such as improved relevance and contextual understanding, it also faces challenges that require ongoing research and refinement. By addressing limitation and exploring future work opportunities, the RAG framework can be further enhanced to provide more accurate, reliable, and insightful support for financial professionals. Implementing comprehensive evaluation metrics and continuous feedback loops will be crucial in advancing the state of the art in this domain, ultimately leading to more effective financial decision-making tools. Limitations in generative approach are the responses take long, like 2 minutes to be retrieved, lack of domain-specific accurate information, or you can call it data quality, computational resources. This can be in form of the database, because the database is very big, like 4 GB, maintaining and also maintenance costs. We use ChatGPT API, meaning every time the API gets expired, we have to get another one. Future works using transformers, using hybrid retrieval approaches to leverage the strength and importance, improve performance, employing cost and resource optimization methods, multilingual and cross-market support, integrating real-time data, enhancing model explainability. Thank you very much.